till the wavefronts, and we did phase and phase difference. Very good. Okay. So speaking about that, then let's go forward and check out what we have. So today we are going to start off with something called intensity of a wave. Now, intensity of wave is defined as power transmitted per unit area by wave. The symbol generally we take for intensity is capital I and the SI units are watts per meter square, like that. So intensity would be power over area. So you have this formula for this, like power, area, intensity. You can also write this because energy over time is equal to power. So if I replace this whole thing can be written as intensity is equal to energy over time over area. Now, I just want to tell you that you can write this and then we're gonna move forward. And if you have a question, please let me know. Okay. So now the two things you guys need to remember is the intensity have certain relationships too. Like intensity is directly proportional to the square of amplitude. What it means is that suppose you see a wave that has an amplitude like A, and intensity of this wave is I. So, what would be the intensity if there is another wave which has everything the same, but now it has an amplitude that is equal to 4a? Okay, so the intensity, sorry, wait, please. So the intensity would be, because it is square of that, so that's going to be 16I. Do you guys understand what I mean? So basically, to quickly do this, generally what I do is I found a way of dealing with this. Like, I'll give you a short formula. Like, if you have intensity of the first wave, if you have intensity of the second wave, you can easily relate the amplitude of the first wave square over amplitude of the second wave square would be related to it. And this will generally give you easy answers to the ratios they're going to give you, because this stays the same. All right. All right. Now, then we could basically then talk about the relationship of intensity is also directly proportional to the frequency square. So like that. What I mean by this is that suppose you have a wave that looks like this. It has a frequency of f and the intensity of I. So if you double the frequency, sorry. So if you double the frequency, everything stays the same, like amplitude, whatever. So in frequency, if it's 2f, then intensity is going to be 4 times of I, because frequency and intensity are directly proportional as well. So this also has the same, you can build this formula that I1 over I2 is the intensity of the first wave, intensity of the second wave is equal to frequency of the first wave square and frequency of the second wave square. That would also give you the correct answer if a ratio comes. All right, any questions, please let me know. Okay, now the third relationship that intensity has, that's when we say intensity is inversely proportional to the distance square. So what I mean by this is that suppose if there is a source say source of light. So the light basically is produced like this, which basically means that if you look at a certain distance at this point, let me make it a different color, it's more visible. At this point, and this point basically lies somewhat at distance x. So we want to know what will be the intensity at 2x distance, which is somewhere here. So you just need to remember that when near the source, the brightness will be, it would seem that bright is more because you're nearer to it, so it's like not spread. But as you go further apart, the brightness becomes smaller and smaller. So which means that if this point has intensity I, then this point will have intensity of a quarter of I. And how do I know this? Because it is an inverse ratio. So 2 times increase in distance would be a decrease by 4 times in intensity. And for this, you can make a simple formula as well. You could say, okay, I1 over I2, that's the intensity of the first wave, intensity of the second, is equal to x2, the amplitude of square of the other wave, divided by this one. So because this is inverse, that's why it's up and down. So you can remember these formulas and they will always help you find the ratios, no matter what ratios they throw at you. And that would be very helpful to you. Trust me on that. Okay. So let me know if you guys have any questions. Okay. Right. All right. Now, so let's do a question and see basically what type of questions basically come in this. So first of all, they say a wave of amplitude A has an intensity of 3.0 watts per meter square. So find the intensity of wave of same frequency at same distance that has an amplitude of 2a. Okay, so they have given you this. Now because it's the amplitude is changing, so I know that the intensity I1 for the first wave, the intensity was this, and for the second, the amplitude was A. For the second one, we want to find the intensity when the amplitude A2 was 2A. So now I can just simply use the equation. I could say, okay, I1 over I2 is equal to A1 over A2, and we need to take square of both of them too. So I1, I can just fill in the values, is 3.0. I want to find I2. A1 was A square, and now A2 is 2A whole square. So further down this, it's going to be, so I'll do it here, 3.0 over I2 is equal to A square over 4A square. A square and A square will cancel out. So I2 will be equal to 4 times 3.0. So hence it becomes 12 watts per meter square. Is it clear? Hamad, Aisha, Javeria, any questions now?
Yes, sir.
Okay, pretty good. Pretty good, pretty good. So you guys understand this, that's cool. So then let's talk about another question. So they say a wave of amplitude 2 meter has an intensity I. Then says the intensity is reduced to half I. Let's say draw the new wave. And they have also given you the previous wave as well, so that you guys can draw that. So here we have amplitude, here we have whatever, doesn't really matter. So they've shown you okay, wait. A wave like that, and that's 2 meters, and that's 2 meters, right? Now you want to draw this. First of all, we do have the amplitude A1, but we do not have the amplitude A2 because of the new one. So we're gonna gather some data. So for the first wave, the intensity is I, and the amplitude for the first wave is 2 meters. I want to find, like, the intensity of the second wave is half I, but the amplitude 2 is unknown, so I want to find that, right? So I'm going to use the equation I1 over I2 is equal to A1 squared over A2 squared, like that. So now let's do that. I, and this is half I, and the amplitude for the first one was 2 square, alright, I'm just going to write meters, 2 square, and I want to find A2, so I and I will cancel out, so this will become 2 times A2 square over 2 square is 4, so A2 square will be 4 divided by 2 is 2, and now I take under root, so I get A2 as under root 2, which is about 1.4 meters. Do you guys understand this? All right. So now the new amplitude is like 1.4, so we're gonna mark 1.4 here. And then we won't change the frequency at all because the frequency is just the same. They never said it changes. So we're going to make the new wave exactly with the same time period, but now with the new amplitude that we found. So this is the new wave. Is it clear, everybody? Any questions now?
No.
Okay. Now there is one more thing that you can do, right? And this is sort of a question where they might give you two things that are changing. Okay. In fact, I'll do one more because that might be important as well. But then we will cover all the, all the things. So it says a wave has an amplitude A and frequency F. Now they've included the frequency. It says a new wave with double the frequency and quarter the amplitude is generated. So it says calculate the new intensity in terms of I. All right. Now let's write the data first. Okay. What we have, what we don't have. So intensity I1 is I, amplitude A1 is A, frequency 1 is F. Intensity 2 is what we need to find. Amplitude 2 is a quarter of A, and the frequency of 2 is 2 times the frequency. So in 10 minutes, bachcho, please rejoin, alright? Now. Acha. So now since we have two formulas, like we know intensity is given by like intensity over intensity 2 is amplitude 1 square over amplitude 2 square, and we also know that intensity 1 over intensity 2 is equal to frequency 1 square, so frequency 2 square, right? So if you want to combine these, right, if you want to combine these, remember you can always write it as, because intensity is directly proportional to A1 square, so and also F1 square, so we can just write it together like that now. So now we can actually solve this up because they are both related to intensity, so we can multiply them, and that would affect the intensity anyway. And now let's put in the values. So for I1, I would say it is I I want to find, sorry, this is I2. I want to find I2, and A1 is just A square, and frequency 1 is just F square divided by, the new A is a quarter of A, so 1 quarter of A square times, the other one is 2F, so 2F whole square. So I've just done that. Now let's solve this up. So I over I2 is equal to A square times F square. This will be A square divided by 16 times, this will be 4 times F square. So if you look at it, it will just cancel out. But here, because 4, 1 and 4, so it will be 4 will go up because it's double dividing. So then the new intensity I2 will be equal to I over 4, and that's the answer we're looking for. Do you guys understand this? Let me know if you don't understand this, please. Okay, cool. You can write this down there. Okay, now then we're going to do the last type of question that might come, and that is that a wave of amplitude 20 millimeter has intensity of Ix. Another wave of same frequency but amplitude of 5 millimeter has intensity Iy. So it says, what is the ratio of Ix over Iy? Alright, so this time I want you guys to do this. Please try any methods you like and find me the answer, please. Alright, go on. Okay. All right. Can you guys please try this? Did you guys get any answers? Anything? Okay. All right. Any answers, please? Hamad, Aisha, Javeria.
Sir,
Yes.
is it 16?
Yes, that's correct. That is 16. Very easy question though. So Ix be Ix is what? Okay, we don't have Ix. Fine. Need the ratio, sorry. So Ax is 20 millimeters and Ay is 5 millimeters. So Ix over Iy would be equal to 20 square over 5 square, and it should come out to be 16. That's as easy as it gets. Okay, that's pretty good. I hope you guys understand this. So I guess we'll stop here because tomorrow then we have to do um, like would like to do Doppler's effect, and it would take the whole lesson. So let's stop it here, and tomorrow we shall meet again. All right, everyone?
Yes, sir.
Okay, that's pretty good. All right, so I'm gonna see you guys tomorrow. Have a nice day then. Bye.